In this tutorial, I'll be showing you guys how to spawn these buildings that I have on my sides, all with little pathways that connect up to the main road network. Now, this is the full city here. Well, it's a really mini city. You can see it is working with random buildings, but it is going and spawning them and making sure everything fits together. And don't worry, you do not need to watch the previous part if you don't want to, although I would appreciate it, because I'll be showing you guys how to set this up for yourself just using regular splines, so you can use the same method for your own project or your own needs without needing to specifically set it up exactly for the city. And that's kind of the goal with all of these tutorials for the city gen, to give you a standalone piece and show you how I implement it together into the city gen itself. Shall we get started? For the setup, we're going to need a few things, starting with PCGEx. It is available currently on Gumroad, and it comes with full instructions on how to install it. It's very simple. You basically download it and put this folder right inside of your plugins of your project. So if your project called CityGen, it'll be CityGen, plugins, and then Extend Toolkit. And then inside of that is all your binaries and all that. Just put it there and you should be good to go. And the great thing is, it is free after all. And for assets, I am using Kenny. Kenny stuff is always great. I'm just using the CityKit Commercial as well as the CityKit Suburban, just so I have a few different buildings to play around with to get started. Everything I just mentioned will be linked in the description below, so if you need to grab any of them, the links are there. And there was a small update to the 5.7 version of PCGEx since my last video, so if you want to grab the latest and greatest, you can grab it there, although it's not fully packaged yet for 5.6. Tim just kind of rushed that update out to fix something that we're going to be going over in today's tutorial. Let's get into it. Now, assuming you brought in everything from the PCGEx into the plugins folder, still go to edit plugins, search for PCG, make sure you have the Extend Toolkit enabled, the regular procedural content generation framework enabled, and the geometry script interrupt enabled. As long as all three are enabled, you should be good to go. As I mentioned earlier, I will be creating basically a single road, effectively a spline, and then setting everything up to it. So that way you could take this and put it anywhere you want, whether it is in this specific city generation system or somewhere else entirely. So you don't need to know specifically how I did everything prior to it, although I do recommend checking out that video. Let's get started. First thing I'm going to do is just make a spline. So I'm going to change my selection mode to modeling. I'm going to select draw spline. I'll make it an empty actor and I'll do free draw with maybe 1,000 point spacing. And then I'll just come here and just drag out a spline. Okay, let's go ahead and accept. And you can see we have a spline actor. Let's go here, give it a tag. Let's just call this road. So we give it an actor tag called road. So that way we know that this spline actor is the road in case we have multiple. Now let's go ahead and right click, go to PCG and grab ourselves the PCG graph. We'll make an empty graph. I'll call this PCG underscore buildings with connections. That should be okay. I'll just take it and just drag it out and make sure it kind of covers the entire area we need. So maybe I'll make it a little bit bigger. We just want to enclose the spline fully inside of this volume. And now let's open it up. We'll start by first sampling the spline. For that, it's very simple. Right click, search for get spline. You'll get spline data. So I think that's the information of the spline, but which spline it is? Well, instead of self, we want all world actors by tag. And the tag we gave it is row. And in case you have multiple, you want to turn on select multiple. So this will find all your splines with a tag road. Now we just need a spline sampler. So that way we can sample the spline and actually get points out of it. On it, I'm going to keep it on spline. So subdivision, we'll set it to distance and we'll set it to be a distance of, let's say, 500. I'll also enable fit to curve. That way basically just adjust that 500 to be a little bit more or a little less, because I don't need it to be exact, just so it fits the actual start and end points a little bit better. And then I'll just grab a bounds modifier, because this is really skinny and really hard to see. I'll use a bounds modifier and scale the Y and the Z by something like 200, just like so. And now if I go ahead and press D to debug it, in the bottom left under debug object, I need to make sure I select my component here, and you will see there's our debug. So if you're seeing this, you did everything right and everything is working. If you don't see it, press A, toggle it on and off basically on this node, and then it should pop up. It's a small bug that happens from time to time in PCG. After you do it once, it usually realizes, oh yeah, we're updating this. Now that we have this basic setup, we can already start using one of the new PCGEx nodes, which is really nice. It is called offset. Now there's a few different ones. There's path offset and there's this clipper 2 offset. And this is the one we want. We want the clipper 2 offset. If I go ahead and debug it here by pressing D, you'll see it looks exactly the same. Nothing has changed. Well, what's the point of it then? Well, it's because we haven't configured anything. In the detail panel, offset is set to 100. Let's set to something like 1500. Well, now we're getting something a little more interesting, aren't we? We're getting a circle around. Now, I've clearly made this spline way too small. I'm just going to redraw it by changing the output mode to existing actor with it selected. And then I'm just going to zoom out. I made things a little bit bigger and make this considerably bigger like this. And hit accept. And there we go. So now you can actually see what's going on. It is effectively taking the single spline and offset the points to either side and has even rounded them out at the end here. Now this rounding you might not want. You might want this to be more square or a different shape. Thankfully, this is actually an option. Over here under end type open, right now it's set to round. We can make this square. And now it has just 2 points there at the end, or but. But basically just has it go all the way to the end and then stops. So it's as though you just cut it off, which is pretty much what we want for our roads. Then there's joined, which slightly curves them in, I think, as though they were connecting to the other section. But the main one we're going to be going with is basically but. This one right here. Now, one thing to note here, and one thing you might have noticed earlier on, is we didn't have an interior before. It is actually smart enough, or if I increase this way too high, let's say 15,000, if it was to overlap on the inside, then it wouldn't be able to fit those points, so it doesn't have those. For example, here's 8,000, and you can see we kind of get this one pushed out, these pushed in, but if I go like 8,200, 8,500, 9,000, you can see where they won't fit, they don't exist. I'll go back to the 1,500, and that gets us the result kind of we want. This right here. Now, there's a lot more controls in the options you can play around with and see how they work. Unfortunately, I can't go full in-depth on every single node, or this tutorial will be multiple hours. So I'll be going over kind of the basic functionality of that node and kind of the things you need to be aware of. But now we have taken one spline and made it two. And because of the way we have set it up, I can go ahead and hold Alt and duplicate the spline, and you'll see what happens here. Where we have things overlap, again, it goes ahead and removes them, which is really good. So it effectively treats the entire shape here as one. It is one piece. Now you can select it to have each spline be treated independently instead of like one. But you can see here, these all pushed in. Instead of having overlapping here, it goes ahead and pushes it in just fine. Now I have noticed that in certain setups, especially with the city gen, I have a few extra points on the inside. So we will need to clean it up a little bit, but overall, this gets us a really nice result. The main problem that we actually get is it split this path, but these 2 points are actually still connected. If I go ahead and do a create spline here, so you can take a look, and then use a spawn spline mesh, and I just put in a regular cube, it doesn't really matter. You will see right here at the ends of these, we're getting this closed off section. Now, I don't actually want this here. The reason I don't want that is because that would mean that at my dead end, where the road ends, I would have a building there. And I don't potentially want to have a building there, or whatever I'm spawning. I just want it on the sides, not at the end. So really, we just need to split this into 2 separate splines at this location. And we can do that using a PCGEx filter by angle, because effectively this is always going to be a hard angle here. So after this offset, I can go ahead and drag out and search for path split. Path is basically a spline, so we're splitting the spline and then go all the way through. It just needs a split condition. If I just right click and search for filter angle, there's a filter angle and an edge angle. We want to get the regular filter angle. And then here you can see curvature if it is greater or equal to 60. And then in the detail panel, we can change that. So dot comparison details is where we adjust this. The domain is set to scalars to 0 to 1, but I personally like to work in degrees because my brain works better that way. But if you'd like to, you can keep it scalar and put in the scalar value. It is a dot comparison. So it goes from -1 to 1. I'll set it to be degrees. And the main thing that we want to actually control here is the comparison, of course, and that needs to be checked that it is less than 90 degrees. We'll go ahead and plug in the filter into the split condition. And on the split, instead of split actually being split, I want to do disconnect. So disconnect the splines where those are. And now if you take a look, you can see we get a better result. There's still a little bit there. If I change the angle from 90 to something like 91, you can see that dead end goes away. And again, this is before and this is after. And you can see we do lose a little bit here in a few little spots. So you can play around with these settings to get kind of a more exact result that you'd like. But really, we don't need to do it that exact. From here, though, I do want to cut out any points that might end up kind of in the corners or in places I don't want. I'll go ahead and detach this spline setup here. This is only for testing. In case we need it, I'll just put it above. If I debug this path split, you'll see there's our actual points. You see the points are still all there. Now I have noticed that occasionally you'll get a point maybe like around here in my setup. So the nice thing is we just need to use a difference node and we can just cut those out. Or something like this where we now have the points here kind of going into it. We don't probably want to have these spawning. So we can go ahead and remove those. We'll just use use a simple difference node here. We'll plug the split into the difference. We'll change the difference to be binary. And I want to go ahead and remove the original spline points. Now, let's grab another bounds modifier here, honestly. So that way I can go ahead and scale the points from here to say, hey, I want them to fit or not fit to basically control the width of the actual road. So if I go ahead and debug this bounds modifier, you'll see that is kind of the quote unquote thickness of the road. But if I debug the split here, you can see, well, actually the road is going to be a little bit thicker most likely. So if we want to now, we could say, hey, you know what? The road is actually going to be 3 times thicker. So scale the points by 3. Now if I take a look now, so with 3x, there's the thickness of the road. So basically, if anything gets within this distance, if we actually say that is a spottable spot for building, that's too close, go ahead and remove it. And if I take a look at the original split one here, you can see that's the actual location where it'll be spawning. So don't put anything here, basically. Now in this setup, again, we won't notice any difference by debugging the difference, except right here where we did cut out a few points. And mostly, again, this depends on your setup. In mine, I found that I had a few stragglers that I needed to get rid of, specifically where intersections were. In this case, I'm not setting up intersections. That was the previous video. So in intersections, I found this to be a problem, which is why we have a difference node. But if you're not using intersections, you probably don't need it. So awesome. This is all working great. I now want to start setting up grammar. I want to use grammar for the buildings for the simple reason where I can have the buildings automatically kind of place themselves based on the bounds of themselves, and they can kind of pack themselves in as closely as they can, really. Even though grammar has still a little bit of issues with bounds and things of that nature, it's still better than having to do it manually and adjust it. I am lazy, and because of that, I'm going to use what's available to me, as in the default PCG setup now comes with a linear grammar tool where we can just grab pieces from the graph and use them. Let's do that. In the top left here, I'll change the selection mode to PCG, and I'll click on draw spline, and then we'll see this linear grammar tool. Let's go ahead and select it. Now I'm not drawing anything here. All I want to do is just double click to open it, and then I can cancel out of here and go back to the selection mode. So this right here is the actual grammar setup. Now we're not going to need everything here. We'll only need a few things. We have our own spline setup. We're good. Really, we just need this apply grammar section where we grab modules, we set them, we calculate everything, and then we set the subdivide spline. So really, it's pretty much just all of this section here that we want. So I'll just take all of this, including the modules, and you can see here, output to be here is debugging grammar. If you want to have that set up, feel free to grab it. I'm just grabbing what is necessary. So this apply grammar kind of main section here, I'll go ahead and copy it, and I'll go ahead and paste it in right over here. Now it's going to throw some errors. That's fine. That's just because we don't have the actual variables here created. Let's go ahead and create the parameters now. I'll go to the graph parameter sections, add a new one, click the little pill icon here. This is going to be of a type string. I'll press F2 to rename it, and this is grammar. And for the default one, I'll just do curly brackets for open close, and then I'll put an A here and a star. So this will be the default, randomly assign A an infinite amount of times. That's going to be our grammar setup. Now I can drag this one in, get rid of the old one, and this one needs to go into the grammar string here. Just go ahead and plug that in, and I'll just bring this over here. And the main thing here is I want to actually convert it to a spline again. So I'll just drag out create spline. So now we're back to a spline without the extra points and the offsets now, and that goes into the subdivide spline. Now it's still throwing a disabled icon here because we haven't plugged in the modules that kind of got destroyed at the beginning here. Let's go ahead and add another parameter. I'll hit the pill icon. I'm going to search for PCG module, and we want the PCGEd mode mesh module info. I agree that is a mouthful, but that's the one we want, the one very top. So go ahead and select it, and then hit this drop down, and then change it to an array right over here. So we want an array of these. I'll go ahead and press F2 to rename it. This is our modules. We'll add a default one here. I'll populate the static mesh with just a cube. The symbol here will be A, just because the default I set for the grammar is just an A. So that is what the symbol is. I'll set it to use mesh bounds by default, and now we're good. I don't want it to be scalable. In my case, I'm spawning buildings. I don't really want them to scale and deform. That's going to look really weird when we do that, especially if you walk up to a door and it's just super wide because it's scaled, right? You don't want that. So we're keeping scalable off. This is fine now. We can just go ahead and grab this, drag it out, and plug this into A and B here. And you can see when we do that, this whole thing kind of lights up. So fantastic. That is all set up for us. The subdivide spline is all set up for us. It's great. Everything here is good. So now we can continue from here. And if we take a look at the original graph, it goes to the points from grammar. And if we look at this, you can see it goes here to the static mesh spawning. Now here it gives you the option of spawn spline meshes. We don't actually plan to spawn spline meshes, so we're only ever going to be doing output A. So if we take a look at output A, it's just doing apply mesh pivot, linear grammar tool, and then we're spawning it. So we can just go ahead and grab all of these, copy them, come here and paste them in right here. So effectively, we just copied pretty much the entire linear grammar setup in here and just re-added the attributes that we needed to make it work. If you take a look, you could see, oh, there's the cubes that are being spawned. Okay. You can see there was a little gap there. That's okay. We'll survive. And if I go ahead and select the PCG graph in the detail panel, I can go open the parameter overrides. We can override the modules. And let's say we want to add a new one. I'll go ahead and add a cylinder in. And you'll see it has not changed anything because we still need to configure the rest. So this is required where we set the symbol, let's say B, use mesh bounds to be true. And the grammar here will be A, comma B. So pick randomly between A and B and then asterisk. And now you'll see, there we go. It is now spawning randomly between A and B. And it's working really well. But testing with this isn't very great, so let's go ahead and set it up with the actual buildings. I'll go here in the suburban buildings and I'll grab one, and we can put that as our A here. And if we go into the commercial, we'll maybe grab another one here. Let's get the skyscraper, and that will be our module 2. Now, one thing you might immediately notice is they are tiny. If I select the engine folder in the content browser and I search for character, there's a few default characters. Main thing is if I drag any one of them, you could see the scale is a little bit off. Now, here's the problem that we're going to face and a few solutions for it. If right before the static mesh spawner, I use a transform points node and I say, you know what? I actually want these to be, let's say, 10 times bigger. Well, it adjusts the scale of these points, but it doesn't adjust the linear grammar scaling, as in the bounds have not been adjusted when we needed them to be. So let's set this up. I'll add a new parameter here. I'll press F2 to rename it. I'll call this building scale. Building scale by default will be 1.0, but we'll be able to overwrite this. I'll go ahead and grab this, open it up, and I'm going to put it into scale min and scale max. It is uniform scaling, so a float here is just fine. But we need to do this transform basically earlier on as well. Over here, this is checking a boolean, use mesh bounds as module size. So if it's true, it goes to outside filter, and then it gets the information. So right here is really where we want to intercept that scale. So what we need to do is after we get the bounds from the mesh, let's move it over to the side a little bit. I'll drag out and search for a multiply. And so the bounds from will be multiplied. And so what we want to multiply is specifically the extents. So you go to point extents. We want to multiply the extents. The extents is basically half of the size of the mesh. If you think of it from the center of the mesh, how far in positive x, positive y, negative y, right? It's basically what is that distance? It's the radius of your cube bounds. So whatever extents it is, we want to multiply it by our value of the building scale. And when we do that, we will overwrite it back onto the extents. Now it's great. It's going to scale it. But there's one extra setting we can put in here that could be kind of useful. What if we wanted to also add a little bit of a gap between each building? One that isn't coming from the size of the mesh itself. We can actually just go ahead and offset that here. After this multiply, I will search for an add, and just like the other ones, we are going to be adding to the extents. Now, really, I only care about adding into extents.x. So since x is kind of the forward axis of the spline, so basically having the building take up a little more space than it actually would need. By default, it'll be 0, but we can go ahead and add another parameter. Press F2 to rename it and call this extra spacing. And we can go ahead and grab it, drag it out, and plug it into NB. And instead of going from the original bounds for mesh, we now come from this add node and plug things in exactly how they were. Thankfully, this multiply is already set up to have specific inputs in one and the other. It is not using at last. If it did, we would need to modify it, but we're good on this multiply, and so the rest follows through, no issues. So now let's take a look. Here are small little buildings. We go ahead and select the graph, and then we go to building scale, and we say we want to be 10 times bigger. And you see that now there's our buildings, and look at that. It is pretty well set up to be placing the buildings right next to each other. No gaps, pretty much. We do have intersections. Okay, so we need to fix that, because obviously the original points don't take into consideration the size of whatever it's spawning. You can only do that afterward, so we'll need to do that. But overall, everything else seems to be working. And again, same thing here, right? The linear grammar can do so much, but we have a little bit of intersections here. Thankfully, we did add an extra spacing option, so we can utilize that. Let's say 200 extra spacing. And now there's a little bit of a gap between each one. And depending on what you want to do, whether it's built to be kind of really tightly packed or not, this might be what you want to do. Just add a little bit of a gap between, let's say maybe 100 gap. It removes a lot of the overlapping in places where it's curving. If you have a perfect grid, this will be less of a problem, of course. But you can see here, the problem areas have definitely reduced, and we have kind of a nice setup here. here. Okay. The other thing that you might notice is they're not facing kind of the spline exactly perfectly. Some of them are pretty good, but especially around corners, right? This building is kind of facing diagonally here, and I really wanted to face more towards the road. This was pretty good, but this one, not so much. And we have a few other ones here and there that are kind of just, yeah, like this one. It'd be great if it kind of faced more towards this road or towards this road, honestly. So let's first adjust the rotation of these to make them properly look at the road, and then we can go ahead and fix up this overlap. Because obviously when we rotate things, the bounds will adjust, and so we'll need to do it based off the new rotated locations. So after this transform points, I'll go ahead and just merge all of these points together with a simple merge points. I just want it all as one big group because we'll be doing pruning. It's going to be all within one, or it's going to ignore every other road. But like I said, first we need to do the angle. For that, we use a PCGEx node. Here you have PCGEx sample nearest point. This is the one we want. So figure out where the nearest point is and then do something. So the merge points goes to the in here, and it wants to know what is the target. The target is going to be our spline here. Now we need the spline kind of in a few locations. So for convenience, I'll just add a named reroute declaration node. I'll press F2 here and I'll call this original spline and plug this all the way through. And now come here and get the original spline and put that as the target here. And then we'll go ahead and plug in the static mesh spawner so we can see what's going on. The main thing we are going to want to go into is the sampling section. The sampling method is right now all within a range. I actually just want to find the closest target. Whatever is the closest point, grab me that one. But let me know what range do you want me to even look in. There's no reason to search within 20,000 units away when at most you'll ever use, let's say 1,500, 2,000. Adjust the value accordingly. It is still picking the closest one. It just has to sample less things, so it's a little bit nicer then. So range min will be 0, but a range max 300 is way too low. Let's say 3,000. We're currently using a 1,500 unit offset. This should be way more than enough even when we add even bigger buildings. So this is a nice kind of safety net. You could go like 2,000. That'll probably also be fine. And now that we've found it, we've sampled it, we have the information, what do we do with it? And that is under the apply sampling. So first we sample, then we apply a sample. You can see apply look at. We'll turn this on. What is the rotation that we want to rotate on? Well, we want to rotate on Z. We want to rotate it this way. Rotate it just along Z to make it look at the whatever it is. If we take a look, well, it's working, but in my case, the axis is wrong. We need to have it rotate not with that forward. These buildings are all set to Y forward, not X forward. So we can just change that under outputs. Here's our look at stuff. There's up vector. There's the align. So under look at align, instead of forward, I'm going to select left. And now if we take a look, the fronts of the houses are now facing towards the road. And everywhere it is now facing a lot better towards the road. And this was the problematic one before, and it's now facing down. If I go ahead and disable the nearest point, you can see where it was before. It was angled way off, but now it faces better. But you can see that these guys are now a little bit off. Well, why is that? That has to do with the original spline's sample count. Basically, it is not looking at the full spline, like every single 0.01. It's doing it based on the samples of those points. So if we want it to be a little more exact, we just need to resample the spline with the density that we want. So we can take this original spline, do another create spline from those points to recreate it, and then resample it using a spline sampler. And this time I'm going to set it to be distance of 100, and I'll still say fit to curve and use that as our target. Now it's definitely more points that it has to look at, but it becomes a far more accurate. So we're going from this, where it's just a little bit off, to this, where you can see these are now very nicely facing forward or towards the spline. You can adjust the spacing there a little bit, depends how exact you want it to be. But within 100, honestly, there's a little bit of movement, but you honestly cannot tell. So this is working really well. There we go. Okay, all our buildings are now facing correctly towards these splines. You can see some of them have doors in the back. Don't worry, this is actually the front. This is the nice front view. They just have doors in the back, so this is not rotated the wrong way. Same thing here, right? This one isn't going this way, it's actually from here. And now that they're facing the right way, this is easier to fix up because we know these are their final positions. So what we need to do is first get the bounds of the mesh. So after the nearest point here, we'll say bounds from mesh, and we need to get it from the information we were using before. And you can see on the static mesh spawner, it was set up to use static mesh attribute name. So we can grab it and paste it right in here into the mesh attribute. Go ahead and get the bounds from there. If I press D to debug it here, you can see there's all of our buildings, and the bounds are correct for its scale and for its placement and everything. Great. And now we can do self-pruning. Now, if I search self-pruning, I do get two options. I get the regular self-pruning, and I also get a PCGEx version of self-pruning. We'll use the regular one first, just so I can show you guys what the difference is. So from the self-pruning, self-pruning, it'll just go right into the static mesh spawner. And on the self-pruning, instead of large or small, all equal, just do randomized pruning. And if you take a look, we don't have many buildings left, do we? There's a lot gone. If I disable the self-pruning, we can take a look. Well, these aren't actually touching. They're not touching almost at all. If you look at the bounds, they're still not touching. So what gives? Well, that's just the regular self-pruning. And I say that because the PCGEx version is so much better. I was talking with Tim a while back about how the self-pruning just filters out way too much. And I'm glad he listened and added this in. Because let me go to the self-pruning one here from PCGEx. Default everything. Nothing changes. Isn't that better? It's still not great yet, but it's better. Also, if I select any one of these and press A, down below it says 68 entries. So with a regular self-pruning, it has 68 entries. With the PCGEx one, we go to 121. We keep basically double of what the original one. Just off the bat. That's pretty good. It is a little more expensive, of course, but I feel the numbers speak for themselves. But it gets even better. Under all this stuff, under all the settings, if you open expansion, there's a precise test. If enabled, does very precise and expensive spatial tests only supported for pruning. We are set to prune, and if you look here, again, 121, if I enable the precise test, 160. Now, it says very expensive. Now, how expensive is very expensive? Let's go have it off, and if I go here, instead of attributes, I hit profiling. You can see here is our total time, 0.001 seconds. If I enable precise test, disable precise test, enable precise test. Oh, well, now it went down. Before it was 0.025, now it's 0.024. Decrease it, enable it, disable it, enable it, disable it, enable it. You can see the cost is extremely low still. It is very expensive if, with two big ifs, you have first a lot of points, tens of thousands, hundreds of thousands of points, and two, it really depends on how much overlap there is between all those points. We, by default right now, don't have that much overlap on majority of these buildings. We added a little bit of extra padding of stuff. We removed a lot of the overlap you would get. Now, if all of these were like overlapping with 5x and you want to do a precise one, yes, very expensive. But this one right now with our setup could probably get away with it with even a larger city. Obviously play around with it if you have a massive city and see what the difference is, but it might be worth it. One other caveat though is it currently has a bug, or sort of currently, I'll explain. There's a bug where it does not work with scaled meshes. So we've scaled this 10x, all the buildings are scaled, and it's working because Tim, bless his heart, pushed out an update just for this video for 5.7 specifically, where precise works with anything that is scaled as well. If you're not scaling your buildings to be 10x, you should be able to do this with the 5.6 version and the previous versions just in general. But if you are scaling the buildings, like I am here because they're originally too small, you need the newest update for 5.7, and whenever he gets around to actually pushing the proper update for 5.7, 5.6, that will be fixed there as well. So yeah. But again, we have effectively gone, if we look at the attributes, from 68 to 160. So if we get rid of the self-pruning originally, and we take a look at this one, well, look at that. That's looking pretty good. Yeah, obviously there's still going to be gaps between the buildings. We've kind of added those in, and we can play around with how much spacing we're adding in between each one. But honestly, that is pretty nice. If you have a perfect grid, you can get away with them being more packed. But if you have a large curved section, you're going to probably want to add a little bit of spacing. Okay, so this is good. The next thing to do then is to add a little road that connects from each one of these entrances to the road. Because right now, let's imagine there's a street here. Well, how do they get from here to here without a little pathway? Oh, we need one of those. And for that, we're just going to use sockets. So sockets are just these points that exist in the world. You can give them a tag and we can sample them basically. So this is one of the buildings that I'm spawning and has a socket. By default, it will probably look something like this. You'll be in the details section. There'll be no socket. So all you want to do is go to the socket manager in the top right, or go to window and make sure socket manager is enabled if you don't see it. Add yourself a socket. It'll be automatically on the ground level, which is great. Move it to the front door, wherever you feel is the center of that front door. You can make it as exact as you want, and then give it a tag. I'm going to call this entrance. So just make sure that whenever you add this entrance for all of your meshes, make sure the name of the tag is always consistent. And you just do this for all your meshes. You may be thinking, okay, well now we're going to do a loop, get all the meshes, assign them, copy the points. Oh, there's so much to do. PCGEx has a node for it. Single node, does everything. I know, it's insane. After the static mesh spawner, just drag out and search for socket. And there's a sample sockets PCGEx node. Go ahead and grab it. And under socket tag filters, we just type in entrance. And the asset attribute that we're checking is basically the mesh. So we want to grab static mesh here, which is the attribute name we're spawning. And that is the asset attribute here. When you plug both of these in, this and the comma separated names for the tags, it stops complaining. And if I press D to debug this, this, you will see a little dot here in front of all of these, already placed, already where you want. And isn't that freaking amazing? When I found this node, I was ecstatic. This is the kind of nodes that I like. They get one simple node, very straightforward to use. I love it. So awesome. We now have this. We now have all the entrances. So now we need to spawn a road and connect it to the main section. Now for the road that is connecting to it, or path, or whatever you want to call it, I did have to make a few modifications to the pivot and rotation of the meshes that I'm using from here. This is the default driveway that it comes with. You can see it is facing Y forward or negative. It's kind of in the middle. So if I scaled it along Y, it scales from the middle. It doesn't go along X forward. So I wanted to modify this. So all I did was I rotated it and I set the pivot to be here. So X forward, and when I scale it, it just goes forward here. And if you want to do this for yourself, you can go under the selection mode and change that to be modeling, and then go to X form, and you can do edit pivot. In my case, I went ahead and duplicated it. So I have a second copy that is a modified pivot, and I named this just X forward. But if your road is already set up like this, then you're good to go. You can do some math and offset it and rotate it. It's just so much simpler to set it up this way properly from the get-go and not have to do a bunch of complicated extra functions. So that's what I did. We once again need to actually get the second point attachment for the road. We don't need it to be exactly in front of it like we did for the look at. It can be a little bit off because it's not as big of a deal to have the road be a little unaligned compared to the building. It could add some personality if anything. So with this, the first thing we need to do is make a note of all of the indexes and the points we're using. So we'll use a copy attributes node. We'll copy from and to the same place. The main thing is I want to copy the index, and we can't overwrite it back on itself. I'll call this road index. So store the index on a new attribute called road index. And now we need to get the point for the nearest thing. So we can use a distance node, and we want to do the spatial distance, not the vector attribute. And on here, I want to output the distance vector. Distance vector will basically tell us from our current point, how far in XYZ is the next thing. So relative to itself, we will know where the next one is. Now, the target is the relative to what? And this is where the original spline sampler, all of this comes in. Now, I could do this. I could keep it at 100 and it will face exactly forward just like the other one did. Or if I'd like to, I could make it go a little bit off, let's say 250. And so some of them will be a little more straight. Some of them will be a little more angled. It really depends on whether you want things to be exact or you're fine with a little bit of leeway. To make it pretty, we'll go ahead and leave it on the default 100. But now we know the offset. If I pressed A here, I scroll to the right, you can see there's our distance in X, Y, and Z, and we know where this point is. So we can just go ahead and add it back to the original position by hitting the plus here, going to point position, and add the offset to it. So if I scroll to the left here, you can see there's a position, negative 7,200X. If I look at the one before it, negative 6,800, because it has now added that offset. And now if I go ahead and merge these points and debug them, and then zoom in, you can see there's our one point and our second point where it's attaching right next to this curve. Okay, there we go. So that is working really well. If you're wondering, by the way, why it's not attaching in the center here, that is based off of this distance using sphere bounds. If we change this to center and center, then it will go from exactly the center to exactly the center here. So now it's along the spline perfectly. Now you can partition them using this road index we were using before, because these new points and the original points have the same road index. So we do a partition, use an attribute partition. The partition here is the road index. And now if I press A here, you will see each one of these has 2 points. Awesome. That is good. So if I wanted to, I could already create a spline from it if I wanted to use spline meshes for whatever reason. There's no reason for it here. We have 2 points and it's single mesh. No reason to make it complex with spline meshes. We're going to just find the distance between the two and basically use that for a scale of a single point. Thankfully, PCGEx has a node for that, basically. Not the full process, but part of it. The node is called solidify. If I go ahead and debug this solidify, you will see now we have actually a single point going from the start to the end from each one of these. And you can see there, it is connected, all of them, with a single point that it's modified the bounds on. So that is already pretty good. So now, using this information, we can now spawn it at this point and scale it by the extents of these bounds. For that, though, we need to know what mesh it is to know how much we need to scale it. So before the solidify, let's go ahead and add our mesh. I'll drag out and search for add attribute, and we want the parameter version. And now in the bottom left, we'll add ourselves a graph parameter. I'll hit the little capsule icon and search for static mesh and grab ourselves a static mesh object reference. I'll make it a cube by default, and I'll press F2 to rename it. And this is going to be our driveway mesh. I keep saying road, but it is in fact a driveway. We'll take that, plug that into the attributes, and we'll name the output target here to be driveway mesh. Okay, that's looking good. So let me get the bounds of the shape. Now I'm going to leave this solidify on its own path here up top. We don't need it for all the math we're doing below. It's not much math, but there's no reason to do the computation extra times. So from here, we'll do bounce for mesh, and we can leave it completely on default because it's already knows to use the last one. The only thing is each one now has 2 points, and we only need the first. I can use a get attribute from point index, because really I only care about the point extents in X of the first point, because it's going to have the same information in all of them. So I might as well just grab one and only grab the attribute of the thing I need. So now from the solidify, we can drag out and use a divide node. We'll divide the solidify by this attribute. I just need to specify that I'm also dividing the point extents in X by the point extents in X here. But I don't want to set it back onto the extents. I want to set it to a new attribute. We'll call this scale X. And now that we know scale X, we can just multiply our current scale by that scale X. So if I plug all the way through here, we get to just modify the point scale in X by the last attribute we just did, and then spawn a new one. Static mesh spawner. We want to do it by attribute, and the attribute is the one we just created here. So I'll go ahead and copy this, and on the static mesh spawner, we can go ahead and paste it in. If we take a look, that's looking pretty good. Now, it's looking a little off right now, but that's because this cube, 1, has the pivot point in the center, and 2, is not designed for this. So let's go here in the parameters of our PCG graph and override the driveway mesh with the one that we want, and there we go. So this is the X forward driveway mesh, and you can see it is going all the way to the end from the actual doorways, and it's going right to the center. Some of them are connecting here. Now, one thing to note here is it is going into the center, right? And based on the thickness of your road, you might not need all that extra scaling into it. Maybe the road's thickness is so you can have shorter driveways. We can adjust that with a simple value. After the solidify, all we need is a subtract node. I'll move these a little bit out of the way. And basically, after the subtract, it goes into int A. And this subtract node now needs the information. We're modifying the extents.x. So I'll copy it from the divide and paste it in here. So subtract from the extents.x a certain amount. How much do we want to subtract? Well, we'll add a parameter. We'll rename this to road half width. Because remember, it is extents, which is half size. Then we'll drag it out and plug that into our subtract node. And now if we come back here and take a look, we can go into our road half width, select it, and specify 5. And now it's a little bit off, 20, a little bit further off. So depending on the thickness of your road, you could have this driveway not go all the way to the actual curve. That is working real nice. One thing to mention here, that the order here of the merge points does sort of matter. If I go ahead and plug in the bottom ones and then the top ones, you'll see it is removing from here, from this point. But if we plug in the top and then the bottom, we go with the normal way, which we want. So I'll actually add a pin here onto this merge points. This is after the sockets, add attributes. So the original path is in and the destination is the in to. So as long as we have it in that specific order, you see here, we are now cutting out things as kind of we want. Then this is looking pretty nice. And the main thing here I want to show, right, is that you don't need the rest of the city to utilize this. You could utilize this for any number of things, which is why I wanted to show this kind of as a standalone before now putting this and implementing that into the actual city setup that we were using. Now I'm going to bring all of this basically into our city gen. It is possible to make it into a subgraph theoretically, and I say theoretically for one simple reason. Whenever I try to do anything by bringing an input in, Unreal would crash. So theoretically, you could make this entire thing a subgraph where you bring in the spline. For some reason, when I try to do it, Unreal just crashes. So I want to let you guys know that that's what can happen. So make sure to save before you try. And in my case, I'll go and just copy the entire thing over. I'm going to come here, I'm going to take this entire graph that we set up, I'm going to copy it, and come here to our city gen, and I'll paste it all in. Now, it's going to throw a lot of errors, and that's fine. Let's go ahead and clean stuff up. So first of all, let's get rid of this original spline. We don't need that. In fact, what we're using is the original city splines, the cut splines. So we're going to search for cut splines, and that's what's actually going to go into this bounds modifier. And that's the same thing here. Wherever we use the original splines, we're now using cut splines. So we'll just copy those over, and there's 2 locations for these, one for the nearest point and one here after the sockets. And then we need to set up the modules and the parameters here. Unfortunately, like blueprints, we cannot just convert this to a parameter. We could do get graph parameter generic or create constant. It's not quite the same. So what I'm going to do is just go into the graph parameters. I'll recreate the setup and then I'll be right back. I've gone ahead and taken care of everything. Only thing is I don't need this original bounds modifier where I scale it by 200x. That's already taken care of. So I'll just plug that all the way through here in the beginning. You can bypass that. And with this in and everything kind of fixed fixed up. You see no errors anywhere. We can take a look and look at our beautiful cubes spawning and connecting everywhere. Yeah, this is not quite right. So let's adjust things by selecting our graph, selecting our PCG component, instance, graph overrides. Let's set things up. And one thing I want to first point out is all of this is out here, and we're going to have a lot of things to control. So we're actually going to first organize this. I think that will help a lot. All you do is click on the drop down for modules, for example, go to category and give it a category name. I'll call this buildings, and then I'll just click away. Don't press enter, just click on category, for example, and it'll put in a category called buildings here. And now I can click and drag things onto this buildings category and basically put it inside of there. Now this road distance increment is part of the original, so we don't want to put that in, but the other ones we can all put into this building section. And now here in the detail panel, you can see it's all nicely under buildings. And honestly, because it is such small spacing right now, let's quickly just adjust things by taking the building scale and making it 10x. So that way it has far fewer points that it's dealing with. And now we'll go back to modules and I can plug in my buildings. Now just keep in mind that the buildings do need to have the sockets set up. In my case, they do. So maybe I'll give 2 of these. I'll tell the second one to be B. And again, use mesh bounds as module. And after you have all your modules in place, we of course need to change the grammar. So I have A, B, C, and D. So I'll just do A, comma, B, comma, C, comma, D. Okay, that is looking pretty good. A few things we still need to adjust, starting with, of course, getting rid of these cubes. So I'll go ahead and override the driveway mesh here. And we can change the road width here to, let's say, 30, a little bit too narrow, so 20. So that way it goes pretty much right up to the road, maybe a little bit inside, but not super far in. And by the way, as a reference to the cutout that I was talking about earlier, I'm going to disable this bounds modifier. So we'll just use the cut splines. And you'll see we get stuff like this, where we have things just spawning basically in this intersection. So to get rid of these intersections, that's what we're using this bounds modifier for, to cut them out. And if we're not happy with this, by the way, we can always just go here and randomize the seed and get a different seed. And of course, this will depend on how big your pieces are and things of that nature. But I mean, I think it's working pretty well. As you can see, you're at more ground level. That's our city now with roads, intersections, and buildings. Now I am planning on actually making districts. I kind of want to do like a city skylines type thing maybe, or city gen games in general, where I want to specify a residential, commercial, and industrial district, have different buildings spawn, maybe under different parameters. So that's definitely something that we'll be going into and setting up in the future. And I hope you'll join me for that. Also, I'd love to know what you think about this format of showing how to set up and use what I'm showing you in the tutorial and then actually implementing it afterwards. Obviously, in this case, the implementation was just copy pasting and just changing a few things. Hopefully down the line, it will let me do the subgraphs. That's my hope. I don't know why it kept crashing. Cannot tell you why, but gotta work around it. Maybe in the future we'll set it up as a subgraph. But as always, you can grab the project files for this on my Patreon, where you can join these wonderful people here in supporting what I do. It really means a lot. And if you'd like to join the community, the links to everything is in the description down below, as always. And if you haven't looked into it, I highly recommend checking out my grammar video. We'll be using grammar quite a bit to get you a bit more familiarized with it. It's a good one.